Okay, a couple of examples of combinations, and how do you know whether it's a permutation or a combination? Don't forget the biggest difference is that with combinations, order is not important, and with permutations, order is important. So something that we've all heard about is Gold Lotto, Division 1 in Gold Lotto. You've got to pick 6 numbers from 45. How many ways can you do this? So 6 numbers from 45 numbers. Given the fact that they're sort of like numbers are picked out of a hat or the drawer, they've got balls, they've got the numbers from 1 to 45, so they've got 45 balls. And we don't have repetition. And the other thing is to remember here, we've got to make our decision whether it's order is important or order is not important. Well, it does not depend on which order they come out in. The numbers, if they come out, well, lucky you if they do come out. It doesn't matter what order they do come out. So the big thing is that order is not important in this case. As long as the 6 numbers come out are your 6 numbers, you win first division. Okay, so because order is not important and we're going to pick 6 from 45, it looks like it's going to be a NCR, not an NPR. So NCR equals n factorial over n minus r factorial. R factorial. Or we can put the r factorial first, doesn't matter. Okay, so n. N is the total number of objects. In this case there were 45 objects, 45 numbers that could, so it would be 45 factorial all over. N minus r. Now r, we're choosing 6, so 6 from 45 is 39 factorial, times r. R is 6 numbers, so that would be 6 factorial, equals 45 times 44 times 43 times 42 times 41 times 40 times 39 times 38, all the way down, all over 6 times 5 times 4 times 3 times 2, I've done the 1, times 39 times 38 times 37 times. So all of those will cancel each other out. And we get this number here, and usually you find that for calculation purposes, some of these numbers, or all of these numbers, will cancel with these numbers up here. So when we calculate all these, we get 8,145,060. So you got one chance randomly, if it all happens randomly, you've got one chance in just over 8 million of picking up Gold Lotto if you just put in one entry. Okay, let's look at another example. How many ways? Can 3 women and 5 men be selected from 6 women and 8 men? Okay, so you're going to choose 3 women from the 6 and 5 men from the 8 men that you've got to choose from. This combines a little bit of two different counting principles. One is just the basic rule that if event A can be done in n ways and event B can be done in m ways, then n times m is the way the two events can be done. So we've got to calculate the number of ways we can get 3 women from 6 and 5 men from 8, and then multiply those two together. Okay, how do we work out the number of ways we can get 3 women from 6? Is order important? I don't think so. So it's going to be a combination. So 3 women from 6, number of ways, is equal to 6C3. So we want to choose 3 women from 6, and then 5 men from 8. Is equal to 8C5. So total number of ways, going back to our original basic counting principle, that it'll be just 6C3 times 8C5. 6C3 is 6 factorial over 3 factorial times 6 minus 3 factorial. So that's 6C3. Then 8C5 is 8 factorial over 5 factorial times 8 minus 5 factorial. Okay, 6 factorial is going to be 6 times 5 times 4 times 3 factorial, and I'll leave that 3 factorial because I know it's going to cancel down here, over 3 factorial times 3 times 2 times 1. So I've gone the 6 factorial is 6 times 5 times 4 times, now instead of writing 3 times 2 times 1, I'll just put 3 factorial because I know it's going to cancel there. Same up here, we've got 8 times 7 times 6 times 5 factorial, all over 5 factorial times 3. 8 minus 5 is 3, 3 factorial is 3 times 2 times 1. Things are going to cancel here. Well, let's do this one first, and 3 times 2 is 6. So that'll be equal to 5 fours are 20 times, now what's going to cancel here, 5 factorial, and 3 times 2 is 6, so 8 sevens are 56. And I think we multiply that out, we're going to get the 0 will go at the end, and we'll get 112, so it'll be 1,120 ways. So that's the number of ways we could choose 3 women from 6 and 5 men from 8 men. All right. So if these, if this was by way of forming a committee, say, and you're going to have a committee of 3 women and 5 men, and we've got a little proviso though. So if Mrs. A will not serve on the same committee as Mr. B. So Mrs. A is one of these 6 women and Mr. B is one of these 8 men, and they won't go on the committee together. We can't form a committee, so we want to know how many committees that we can actually make up. So the total number of committees, or the total number of committees will be the total of all committees, which we've just worked out here, minus the number of committees with A and B. So with Mrs. A and Mr. B. So we're going to look at, if we can calculate that and just take it away from the total committees, that'll be the number of committees that we can actually form, because all of these cannot be formed because A and B, but we'll look at the number of ways that we can get both A and B on the committee and then subtract it away from all those. Now this we've already calculated as that. So if we look at, say, the females or the women, we want to choose, how many have we got though? We've got 6. One, 2, 3, 4, 5, 6. We don't need that one, do we? Okay. Now, we know we want to form a committee, we want to choose 3 of these, and we want to make sure that A is included. So we've got A there. There were 6 all up, so there are 5 others. Now we want to choose 2 because A has got to be one of our 3 women that we're going to choose. So we want to choose 2 of these from those 5. And then we'll have our committee of Mrs. A plus 2 more of those. Now, how can you choose 2 from 5 when order is not important? There's just 5C2. And if we look at the men, we've got 8 men to choose from. Mr. B is, we want to find out how many committees would have both of these on. So we've got another 7 left, and we're going to choose another 4 because, so we've got 4 from 7. Why from 7? There are a total of 8, and we want to choose 5 men, but Mr. B has got to be on there. So that's one of our 5, and there's 4, we've got to choose 4 from 7. Now how do we choose 4 from 7? Be 7C4. So that will be, if we multiply these two, this will be the number of committees that will have both A and B on. Now if we take that away from the total number of committees, that will be the number of committees where both A and B are not on the same, not together. So that'll be the total number. So therefore, if we combine all that, number of committees will be equal to 1,120. That's the total number of committees minus 5C2 times 7C4. And I think that 1120 minus, this turns out to be 350. So there'll be 770 committees that could be formed without both A and B being on the committee. All right, so that's a little bit more difficult, a little bit more involved than some of the straightforward calculations, but you can see that it's important to understand and to look to see whether order is important or not important. That will determine whether you use permutations or combinations. And then once you've got that, you can combine your different techniques to actually work out the different scenarios.